Thank you. So thank you all for coming out. I really appreciate you coming out here and supporting the community, SacJS, and also myself coming up here to speak. Just a little bit about me. My name is Billy Lee. I work at a company called CLC Incorporated. It's a legal referral and was a financial coaching agency. I create the web apps. We do some light functional programming there, and I was hired there to do some sort of functional programming as well, which brought me to teaching this lecture. So just a real quick disclaimer. I am not an expert, okay? So there are people probably in this crowd that knows more about functional programming than myself. And I just started really digging into it probably for like the last month, and it's been a real head scratcher, but it's been very fun as well and rewarding. So what am I going to talk about tonight? Tonight I want to talk about what is functional programming, the difference between imperative and declarative programming paradigms, pure function, side effects, immutability, the basics like using map, filter, and reduce, currying, recursion, and the third-party libraries that we use at CLC Incorporated, and also additional resources if you are interested in learning more about functional programming. So what is functional programming? Well, functional programming is a way to write code that kind of relate to mathematical concepts. And the origins of it kind of stem from, if I'm right, I think it's lambda calculus. And what it is really saying is pretty much for every function, you have, for every set of inputs, you have the same amount of outputs, right? And we're going to talk more about the imperative versus declarative way. But basically, with functional programming, you don't have this thing where you're creating side effects on the other side where you're calling different functions to do certain set of things. With the functional programming, you just have a certain amount of inputs, and it gives you the same amount of outputs. So imperative versus declarative programming. Imperative programming is basically where you tell the computer step by step how to do something. It's very like instructional in a way. And declarative, for those of you that write React, is very declarative. We just declare an expression, something like, you know, if I have a variable and I call it num and I set it to the number 7, that's very declarative. I just declared that that variable num is equal to 7. Whereas a imperative way, for example, would be like this for loop. So it's kind of funny. I kind of used one of my interview questions here, but we're going to set these two variables up here, let drinking age, or the drinking age and of age, and then run it through a for loop. And basically what it does is if they're of age, it's going to put them in a new array. And you can see that this is not verbose, meaning there's not that many lines of code, but in imperative programming, it can get very verbose if you're in a company or existing code base that does that. Whereas something like, does everybody understand this code? Just a little bit, okay. And then for declarative, you know, just sizing it down, making it very declarative about what we're going to do. So same thing, I have two variables up here. I have a drinking age with an array of numbers. And then what I'm doing is I'm just filtering it through just to basically return all the ages in a new array. And that's going to be assigned to of age. And that's pretty much very declarative. And you can see that it's very easy to read. And that's really what's great about functional programming, is that you could write it in a way that's very declarative and easy for either you, the author, or maybe someone coming into your code base to actually understand what's going on. So great, I'm learning, right? So you know, when I first figured this out, I was like, right, this is awesome. And you know, that's why I kept on diving in further into functional programming. And then when I got to like pure functions, I was like, okay, what's going on here? And since JavaScript has first-class functions, which are basically, you could assign functions to anything, like you could assign it as a method on an object, you could assign it to a variable, you could actually have function return functions. So that gives the capability of JavaScript having something called higher order functions, which is pretty much a core concept of functional programming. But pure functions here is basically any pure functions outputs are determined by the inputs values without any observable side effects. So that's a really important key word there is no observable side effects at all. And what goes into pure functions gets computed internally with that functions within the scope of that, and also return a value, right? It could be transformed, it could be whatever. So that is what pure functions are. So we have things called side effects, and side effects is anything that modifies some state or calls another function that is outside the scope of that invoked function. For example, if you have a function that does something and you want to debug it or whatever, usually we just throw in a console log to show us what's going on with that code base, right? So that right there is actually a side effect. It's unwanted. It's outside. It's not passed in as an argument into that function. So what happened is, that's what causes the side effect. And the reason why we don't want side effects is because if, let's say, for instance, let's say you have a function within a function that's calling something, you don't know what that other function is doing, right? You're not passing it as an argument. You don't know what's getting returned from that function. Therefore, you don't know the predictability of what's that function is returning, basically. Another thing is changing a global variable. That is also another side effect. And also calling other functions with side effects as well. So I wish I had more examples, but I do have so pretty much, yeah, I just lost my punchline for that one. But anyways, a simple example of side effects. So going back to my previous code base with the for loop, if this constant up here, minimum age is equal to 21, that is outside the scope of this function right here, the check age. So when I am basically trying to find a value of check age is 24 if it's above the minimum age, it's going to go through this code right here. And what it's doing is it's actually calling minimum age. And that right there is not even being passed in at all. So therefore, it is a hidden input. You might hear this as a side cause. I was reading an article about side effects that for every function that you write, there may be two hidden inputs and two hidden outputs. And usually when you're calling a function that's returning something within that function, that will be a hidden input or a output. So just be aware of that. And I could probably link that at the end of my my slides. Is everybody with me? So if you, sorry, I know we're not supposed to do it until the end, but sorry.
Totally fine. That's good with it.
Cool. So if you had the minimum age inside of the function, would that still be a hidden input or no? That's definitely a good question. So his question was, if the minimum age was inside the function, would that still be considered a side effect? Is that your question?
Side cause.
Side cause? So basically, no, that is not, because that is within the scope of the function. So I think I have an example of that. Nope, I don't. But yes, that is not a side effect. So if that, that variable is within the let's go scope of that function, basically it will be considered not a side effect at all. Okay? Or you could pass it in if you actually pass it in, let's say right here, as an extra parameter.
Yeah, that's what
that,
I'm thinking, if it's not passed in.
Yeah, exactly. If you pass it in as an additional parameter, then that's not considered a side effect. Because the reason why we write functional programming is declarative. We want it to be able to predict it. Because when it comes to testing, it's a lot easier to test something when you know what you're putting in and then what you're expecting out of it. That makes sense? Cool. Yep. So immutability. So immutability is basically data that cannot be changed once it's created. So the reason to treat data as immutable is to prevent side effects and also increase transparency and also allow for mutation tracking. So I'm not sure, I've never done like time traveling debugging, but I think based on Redux, this is why we have that, is the immutability. So you can actually see what's happening as the state changes over time without actually affecting the actual object that you're trying to mutate. You're actually creating copies of it. So that's why we have immutability. So here I'm going to talk about the basics. You have map, filter, reduce. The core of everything from these two, the first two, map and filter, can be built off of the reduce method. Here, map is basically, it iterates over a collection and transform the values and returns a new array with the transformations. And then filter is pretty much you filter, it iterates over a collection, returns a Boolean based on a predicate, and a predicate basically means like if it's true, it's a truth or falsy value. It's just a Boolean. And then if it is true or whatever, it will return that element back into a new array. And then once it iterates over that whole collection, it will pass you the whole new array with the new elements. And then reduce is it iterates over a collection and accumulates a value based on the current element in an array and returns an accumulated value. So, and some examples. Well, I don't have a map and filter. Let's see. Nope. So here how reduce works. Basically, this should be called sum. It would be something simple like that, but I forgot to change it. So you have an order array right here assigned with 5 different values. And when you reduce it, you pass in these different parameters, which takes the previous element, the current element, and the index of the element, and also the array that's passed in. But for the simplicity of this, we could just go ahead and use 2 of the parameters that's being passed in, and we're returning previous plus current. Now, you can actually initialize the current accumulator value right here, which is the second parameter to this reduce function. And here I'm setting it to 0. So as it's going through over each element in an array, what it's doing is just taking the previous, which is 0, and then it's taking 1 and plus and current, and return it back into a new array, or not a new array, but a new value. And then after that, it will spit out, if I call new array right now, basically I'll just get the value of 15. So that's how reduce works. And if you want to try to write it yourself in a for loop, it comes really handy for you to understand like what exactly it's doing, because this is pretty much the core of like, you know, your for each and filter and map and everything else. And after that, here I want to talk about currying. Currying is when you have a function that is partially applied, okay? And by being partially applied, is able to take in additional arguments and basically act on those different arguments one at a time. So a simple example here is adding. So here, if you read this, basically I have this function that's inside this function of add, and basically it's returning x plus y. So if I call this function right now add 3 and 5, because 3 is x, and y is 5, it's going to return 8, okay? But this is not currying at all, right? Because currying is basically partially applying my function. So here, I am creating a new function, a new variable called add 5, where I pass in the parameter or a argument of 5. And what that looks like now, if I just type in add 5, it will look like this. It will basically be a function which takes in a parameter of y and basically return x plus y. So what JavaScript does is it actually kind of remembers what x is. And so when you actually pass in a second argument right here and call it, and here I'm calling it with 10, it will actually give you 15. So that is what currying is doing. And then recursion. So recursion is when a function calls itself as many times within the program context. So it keeps on executing and executing and calling itself until some conditions is met, and then that's when it stops. So I really don't know how else to explain it than just show you what recursion looks like. So this is basically what it is. All right. So it's basically keep on calling itself until is not being called anymore. It's just calling itself. And what that kind of looks like is if I have a function called countdown, and basically I'm passing in a number, and right here on this line right here, it's calling itself. So what it's doing is if the value is greater than 0, basically I'm going to log it out, and basically I'm going to do my recursion right here and subtract it. And then when it's done, when it's above 0, go ahead and return that value. And then when I call it with countdown with any number, it's just going to count down from that number all the way down to 1. So that's what recursion does. So that's pretty much like the basics. I didn't get into like higher order component or compositions, because that's still kind of like out of the scope of my knowledge. I'm still learning that. But if you want to like take a look at some of the different libraries that helps you writing functional programming, there's Lambda.js, which we use at work, and also so Lambda.js it follows functional programming rules, but it does allow mutability. And so if you want to be able to start trying to like try to make Ramda work with immutability, you have to use this extra additional library right here called Ramda Fantasy, which follows that specification of Fantasyland. And if you go to the GitHub, they actually have a really good cookbook. So this is the website, and if you go over, click on the wiki, basically it'll have a cookbook, which is what functions should I use, and a cookbook. So here you click on the cookbook, and it'll tell you what you can do with it. But usually I go to what functions should I use, and basically it'll just give you a list. So if you're working with a list and you want to do something with it, you could just go ahead and pick something from this list of things, and then it actually goes down to logic and object and everything else, which is really nice to use. So how I feel about function programming now, I mean, when I first started, I really enjoyed it, right? And then as I started getting into it, I just went kind of crazy. So that's pretty much how I feel. Like my brain would just kind of like splattered. It was just like done. I spent like a whole night trying to read a really good book called The Inadequate Guide to Functional Programming. And I got into like a couple of chapters, and it was just kind of lost me. So, but additional resources and further reading, you could go to these 2 links. This guy curated a really good link with React and Redux. He has a blog right here, and it's called Functional Programming Markdown. And then another good resource for you is the second one, which is kind of very similar, but the first one is a lot more, has more resources. So that's pretty much it. Thank you for your time, and yeah. So if you have any more questions, I'll be here after the second talk. So thank you.
Have any questions for Billy?
Currying.
Yes.
That's something I always found interesting, but I've never found a purpose for it in like a production environment. Do you guys use that for anything production? Could you give me an example if you do?
I don't have an example. I'm sorry. Yeah, but I'm pretty sure it exists in our code base. I just haven't ran across it yet.
Yeah.
But I don't know. Maybe I'll get back to you on that one.
Okay.
Yeah, I'll ask one of my coworkers. Yeah. Yes.
Why do you guys specifically focus on functional programming at work?
We don't primarily focus on functional programming, but we want to be able to incorporate it because my manager is really big into like testing and kind of functional programming. So he encourages focusing functional programming, but it's not always a thing. So we have the freedom to write what we wish, but to be able to write in a functional programming way, I would think that it would just be easier to do a lot like testing, and it also makes it more readable. So I think that's the reason why we kind of want to move towards functional programming, but it's not necessary at my workplace. Yeah. Hi, Erica.
What are the specifications of Fantasyland, and why is that so bad?
So I don't know too much about Fantasyland, but it definitely follows like mathematical concepts or something like that. I am not sure about what it is, but I was looking into it, and I think it's definitely something we should be using at work. So, so. Any other questions? Yes.
What's the biggest benefit you feel like you've gotten out of learning functional programming?
The biggest benefit, I believe, is I think it's easier to understand, to be honest. I think it's just a lot easier to understand exactly what the code base is doing. So when I'm using the library called Ramda, even though I don't know like some of the things like evolve and everything, I could just look at the documentation, and they have something called type signatures, and I could actually see like what the type is supposed to spit out, and I can actually read that and understand what's going on. So I think the biggest benefit is readability of the code base.
Any other
Yeah.
questions? Nope.
Yep.
All
All right.
Thank you, Billy.
Thank you.